Hello, so in this video we will study about the predicting spontaneity of processes, how we can predict whether any process will be spontaneous or not non-spontaneous. So in mathematical it is very hard to calculate the delta S of universe, means it is very hard to calculate the change in entropy of the universe. So there is an easier way to predict spontaneity for a process by analyzing system involved, and that term is called Gibbs free energy. So what is the Gibbs free energy? According to definition, Gibbs free energy means the energy associated with a chemical reaction that can be used to do work, right? So the free energy means the energy associated with a chemical reaction that can be used to do work. So for an example, if you are doing any reaction and you are getting some energy from that reaction, and you can use that energy to do something work, so that energy will be a Gibbs free energy. So we'll see few examples to understand more about the Gibbs free energy. One example is this one, which is a additional meaning of delta G, and Gibbs free energy is represented by delta G. Basically this is change in Gibbs free energy. So the free energy is the energy available to do work. This is the definition, and here there are two reactions are shown. Number one is copper oxide when solid decomposes into copper pure and oxygen, and copper and carbon is reacting with the oxygen to make carbon monoxide. So basically this is the reaction by which copper oxide turn into pure copper. And so from the mine, when we get the copper, it is in the oxide form, and when we burn this copper in the charcoal or in the coal, so this is like a coal, carbon means coal. When we burn coal, we generate carbon monoxide, and this much energy come out, delta G at 375 degree this kilojoule energy come out, and for turning copper oxide to copper 140 kilojoule energy is required. So basically if we are burning this carbon in the, basically we are burning coal, so we are generating some energy, and that energy we are utilizing this energy, which is called the Gibbs free energy, to use to do work. And what type of work? We are removing the oxygen from the copper oxide. Basically it's like a reduction. So here oxidation state is 0 and here oxidation state is +1, so it is going from +1 to 0. So for reduction of the copper oxide to copper require this much energy, and that come from the burning of the coal. So this is one example of Gibbs free energy. Another example is this actually this is C6H12O6. So this is like a glucose. When we basically this is like a metabolism in our body cells, and when we eat the food and it metabolize into some simple form, and eventually it goes into the glucose form, and our cells utilizes this glucose, and when we inhale the air by breathing, when they utilizes the oxygen, so oxygen is burning glucose and producing carbon dioxide gas and water, and this much energy, 2880 kilojoule energy come out. So this energy we utilizes to do all our daily life activities, and this energy is called the Gibbs free energy. So this is like a metabolism of in our food in our body, and whatever the energy is coming from the by the metabolism of the food or glucose, we generate some energy, and that energy we utilizes to do work. So this type of example, these are the two examples to show that what is the G and what is the Gibbs free energy. So Gibbs free energy is the energy which is available in the chemicals. So this energy is available in the chemical and utilizes in a chemical reaction. It is coming out by the chemical reaction, and then we can utilize that energy to do work. So we'll talk about a little bit more about the Gibbs free energy. And if you remember the previous slide where we study about the relationship between the change in entropy of the universe and second law of thermodynamics. So we establish this equation from the relationship between the change in entropy of the universe and second law of thermodynamics, where minus T is temperature, delta S of universe, this is the universe, is equal to delta H enthalpy minus temperature and delta S. And according to Gibbs free energy, by definition for a system, this is the mathematical equation which is equal to the Gibbs free energy. And Gibbs free energy says that delta H is equal to minus delta G is equal to delta H minus T delta S. And if we compare these two equations, we will come out that delta G is equal to minus T delta S universe, right? So where G is Gibbs free energy, kilojoule per mole, delta G is focus on the system only, delta H is change in enthalpy, and T is in temperature in Kelvin, delta S is change in entropy of a system. So this is an important reaction you need to understand or memorize. What is the relationship between delta G equal to delta H minus T delta S, and how we can correlate these two equation. So what we can get the result from this one, that a process will be spontaneous at constant temperature and pressure if delta G is less than 0, negative. So if delta G is less than negative or less than 0 is or negative, is equivalent to saying that delta S of universe is more than 0 or positive. So it means, if you remember the spontaneous reaction in any spontaneous reaction, delta G of universe increases, and we can also say that if delta G will be less than 0, then delta S of universe will be positive or more than 0. So for a spontaneous process at constant temperature must be constant, and pressure must also be constant, then delta G will be negative, and if delta G is negative, then we can say that the process will be spontaneous. So we'll see one more relationship between using this from this equation. If delta G is less than 0, then reaction is spontaneous in the forward direction, and at constant temperature and constant pressure. So if constant pressure is there, it means the enthalpy will be constant, and temperature is constant, then we can get the delta G will be negative. If delta G is equal to 0, reaction is considered that it will be in the equilibrium, and if delta G is more than 0, reaction in the forward direction will be non-spontaneous, but the reverse reaction will be spontaneous. So these are the three very important results from this equation, from Gibbs free energy equation. How we can get the information from this equation, how we can predict about the reaction, whether it would be spontaneous or not. And another next most important slide is this one. This is the most important slide. This slide must be handy for you to memorize this one, that delta G equal to delta H minus T delta S, where, and you have to remember that temperature must be equal or more than 0 degree Kelvin, right? So in that case, and for spontaneity delta G must be negative or must be below 0 negative. So how we can get the negative value from this equation? If delta S is more than 0 and delta H is less than 0, or we can also say that delta G is equal to delta H minus T delta S. So if delta H is negative, and delta S is positive, if this is the situation, and temperature must be more than 0 degree Kelvin or equal to the 0 degree Kelvin, then delta G will be negative, and in this condition delta G will be spontaneous at all temperature. Another condition, if delta S is positive and if delta S is positive, it means entropy is very high, and if delta H is positive, both are positive, then delta G will be negative. In that condition delta G will be negative, and only if the temperature will be high. So here if temperature will be high, then this value will be high, means negative value will be high, then only G will be very high, right? Third condition is if delta H is negative and if delta S is also negative, both are negative, then we will get the delta G also negative, but only if the temperature is low. So in this condition we have to, temperature must be below or low condition, then we will get the negative value. The fourth condition is this one, if delta H is positive, more than 0, and delta S is negative, then we'll get delta G positive. In that case, non-spontaneous reaction at any temperature. So you have to understand this slide, and these are very important slides. You need to memorize once again. I have another version of this slide that you can utilize or you can understand in this way also, using same equation here, that delta G is equal to delta H minus T delta S. And if here you can see, compare, let's compare this one, negative positive will get spontaneous reaction at all temperature, spontaneous reaction at all temperature, right? So this table and this slide is equal. This is another one more way to understand. Positive negative, positive H, delta S negative, never spontaneous. Negative negative, spontaneous at low temperature. Positive negative, positive, spontaneous at high temperature. The four possible combinations of the sign delta H and delta S used to determine spontaneity of the chemical reaction. There is one more very simple convention which I came to know from this slide, that if delta S is A high and delta H is low, then it will be spontaneous at all temperature. If both are high, then delta G will be 0 and delta G will be negative only at high temperature. So basically it means they are positive and positive, right? So this side will be positive, this side will also be positive, this side is positive, this is negative, and if we have negative negative on both places, then delta G will be also negative but at low temperature. And if we have negative on the delta S and positive on the delta H, then no non-spontaneous reaction. So these were the convention or prediction about the spontaneity of the reaction using delta G or Gibbs free energy.